This panel, we are talking about materials. We've talked about sustainability in a lot of different ways during this session. We've looked at prefabrication causing sustainability. We've looked at speed, saving costs. We've looked at the digital approaches to sustainability and 3D printing in the last panel. And there are lots of different approaches to sustainability, different ways in which we can approach sustainability. We have in this panel the title looking at reducing the footprint of industry. And that could be in terms of carbon, it could be materials, it could be in terms of harms to the environment or things like that. So I want to ask the panel to just highlight some of the areas that they think are the most important harms that we could minimize in terms of the current practices. What are the key targets that we should be looking at?
Okay. Hello, everyone. We just want to talk about material, and one of the material used in our industries is cement. I'm a structural engineer, but I'm also a certified sustainable professional. So that's why I saw both sides. We love as an engineer, structural engineers, the concrete, but in the same time, I have the position to witness the hidden ugly face of the cement. I will give two examples because all the people talk for concrete and cement about the carbon footprint and the CO2. And there is another two aspects you mentioned is materials and the harm. So for the material, I witnessed construction of cement factories in Sudan. They need cement, and they have many factories there, but they lack of the most important material needed for the cement, which is the limestone. So they don't have the limestone, and the only rock needed with a similar composition is marble. So I witnessed destruction by dynamite for mountain of precious, beautiful mountain of marble just to turn it into cement. And the other issue is the harm. I saw in many developed countries, the cement factories as a place, as a location, as an impact on the environment, it's not impacting only the people, not only the laborers, but the environment itself of this cement factory. You can just give an example that it is a hell. It's exactly like a hell. It's a lot of pollution, a lot of dust. The people there, the labor there are having even gray skin, and the plants around the factory are dying. The people around are suffering. So there is a lot of painful impact of this cement which needed to be replaced by another material like polymers and any other material as a bonding agent for the concrete. And I think we have the ability and the technology to have this by chemical analysis to replace this material.
Yeah, the environmental harm is significant. What would you say is?
Of course, I will concur with Dr. Khaled and I will build on it. So I work for a developer, and so from a developer's point of view, the biggest challenge for us, and this is not in the regulation, but the biggest challenge for us is to deliver on housing and schools and buildings with a much lower carbon footprint. Now today, DM doesn't require this from us or Abu Dhabi or any other regulatory authority. But in the years to come, there is going to be a price tag, call it a carbon tax, environmental tax, on how we build. And so as a developer, I see the liability, I see the risk, I'm going head on, facing that risk. And so we have to, and having now worked in the sustainable city in Dubai, we have to look at ways to decarbonize that construction industry. And cement and concrete, or due to cement, concrete is very carbon intensive, but there are opportunities also in the construction industry to decarbonize cement. And so there are some interesting initiatives. They all need much more support, R&D, innovation, and that's not going to come from a developer. That's going to come from the government / scientific / private sector community, We have to come together to find those ways. And so ultimately, we see as a great challenge how to deliver on housing and construction with a carbon label, because ultimately we have to disclose that carbon footprint. So we use softwares, those were perhaps mentioned yesterday during the course of yesterday's discussions, but then I have to dissect my bill of quantities, and I need to add a column at the end, which actually looks at embodied carbon for tiling, MEP, piping, concrete, etc. Now, we don't want to be distracted in the details. We want to focus on the low-hanging fruits, and those are typically linked to the superstructure. So the shell and the core of everything that we build represents about 80% of the carbon and environmental footprint. So this is where the focus needs to go initially. We can spend hours and days and months debating fit-out, green fit-outs, etc., but this has a very little impact on the totality of our environmental footprint. So that's the challenge that we see as a developer, and we're doing our part to go the extra mile, to be a bit bold in our decisions, and to consider alternative materials.
I find the legislative side of this interesting. I think we will come back to that. And the approach to getting to zero carbon is going to be fascinating. What would you say was the biggest harms that we have at the moment?
Thank you, Stephen. What we see, being a multinational manufacturer and fastest growing industry in the region, what we noticed in the last decade is about 75 to 80% of the construction waste comes from building material, actually, which is pretty heavy to carry forward. And when we talk about embodied or the operational carbon footprint or emissioning, it's still not controllable at the moment, but certainly I think today, the last 2 days, what we've seen is a lot of stakeholders who really get up to make sure that we follow the target and lead this forward. As a responsible manufacturer, I think I have two hats to play here. One is the one, how responsibly are we manufacturing actually today? And I think it's clearly what engineer Karim is talking about, and Dr. Khaled as well. How responsible manufacturing, and there is a responsible user at the same time. These are the two sides of the same coin. Now, in between, we have a price tag, clearly. I think, I know there have been a lot of talks about incentivizing this approach. We have very good examples in the UAE. We have Masdar, clearly a successful project. We have clearly clean energy available, nuclear projects, Baraka, you can see that. At the same time, you also see we have several solar parks. So energy is not an issue now. It's a usage of what we're doing in the materials is the key now. So we are an importing nation. Where I saw today, I think Mohandas Mash'al and Benoit from the basics 3D, I think there's a lack of technology, what we're missing in the industry. So clearly what I saw in the last 2 days, again, I refer to that as modular housing is the future. 3D manufacturing can see that as the future. Is that enough? Is what I'm asking myself now. How the future of the factory looks like in the coming decades. Not even decade, actually, we don't even have that much time. We actually have maybe 3 to 5 years max. Because to reduce the temperature to bring it to 1.5 degrees Celsius, it's within 2030. We are already at 2022 end. So I think this is a tall order. This requires all the stakeholders from the manufacturing community as well as the users as well. It's a combination of factors to reduce the footprint. It's not only one side which has to take the load. The legislation for the building material usage, green building is already existing from 2011 in the UAE, by the way. It was mandatory only for the 14 government buildings in 2011. By 2014, it became mandatory for all. That means there's still a gap. We have to approach this systematically through the usage and you apply this digital transformation into the industry. So I think this is how I see this. Addressing only the building material, raw material, it's a very far out cry because we are importing nations of the raw material. I think the technology will bring a new transformation of the usage, and we need to leverage that today. We see BIM a lot. I mean, I saw a lot today and yesterday as well, BIM, QTO, power manufacturing. I think these are the really existing solutions, and we need to make sure that we really optimize this and upscale this into the coming projects.
Yeah, there are some very interesting exemplars across the country. But the challenge is whether we can make everything into an exemplar in order to get to that 1.5 degrees C. And that really is a major target, a major issue. I'm conscious of time, but I want to start exploring the materials element of this section. And I've got two elements of this. One is, are there any relatively near targets that we can get to, some small changes that we could say, this is something that we can do now in order to improve things? And are there things that you might see over the next few years as a development in material technology, the things that are on the horizon that we might see coming in that will help us to get towards this target? Should we go in the same order?
Okay. Right now we have a very good advance in technology regarding the material itself. A very good example that the usage of glass fiber and carbon fiber, which is more strong than the steel itself. So I believe that using the polymers and using the nanotechnology in developing material, this can be doable in the very near future if we have the will to do it. So the technology we have, and I think if we have enough passion and will to reduce the carbon fiber and to save the planet Earth, we have the technology to replace the binding agent, which is the cement, for example, with another polymer or similar material which can be used with the concrete. And then reusing of the demolished building, which we have a lot of building now being replaced, demolished. So enhancement of using this recycled building, the material itself, we get it from the demolished building, we can enhance the search, how to use it more effectively in order to reduce this waste, as mentioned about we have a lot of waste in our construction. So I think this is not so far, it is very near and it is doable, and we don't have time to waste more.
Could I just quickly, what are these polymers? And what are they, how are they used?
Yeah, we can use the polymers like epoxy, and there is some similar material which have the bonding more strong than the cement itself, and we use it in the repairing of the structures. And a lot of civil engineers know that we use the epoxy as an injection to bind the cracked concrete. So it is more strong than the cement, and it can be replaced, the cement. The problem is we have another issues with the fire and how it will act with the temperature. It can be solved by insulation or adding modification to the material itself.
I think it's a good question, short-term, medium-term, long-term. How do we transition? We're not going to decarbonize the construction industry overnight. It's going to take some years. But we have to achieve a certain milestone. The first milestone to achieve all of us, as humanity, society, construction, is 50% emission reductions by 2030. That's only in 8 years. So short-term, we've already tried or started playing with new materials. And I'm going to give one example. I spoke about superstructure and facades. So typically these are concrete walls again, but they don't have to be. They don't all have to be bearing walls. So what if we replace those high density, very heavy concrete walls with something called lightweight facades, lightweight walls? I'll give you a number. 1 square meter of a typical precast wall weighs about 600 to 700 kilograms. A lightweight facade, you can drop that to below 100 kilograms. The carbon footprint may be the same, however, the entire structure becomes lighter, which means my columns, my beams, my foundations, I can downsize them. I have savings. So this is something we can immediately do, and this is now tried and tested in the UAE and beyond. There are some big names in the industry that provide lightweight facades. Thinking more medium term, ultimately we have to start replacing concrete with something else. And that something else has to come from nature. We often talk about wood. This is not a wood-producing country. However, we do have access to cross-laminated timber. CLT is a wonderful product. You can see, and we do see it in Dubai, by the way. If you go to Fit Republic, you look at those spans and those beams, they're made of cross-laminated timber. it is something that we can integrate into our structures, and we're not going to end up with wood houses like in Switzerland and France. However, we can consider hybrid structures. So to what extent can I bring in and substitute some of that concrete with cross-laminated timber or high-density bamboo? This is something that is now being practiced from Egypt to Malaysia, Indonesia. Sooner or later, we will be able to also deploy that in the UAE, but we need to have the right skill sets. We cannot just import the product. We need a different skill sets, right? Different machines, different tools. BIM needs to also recognize cross-laminated timber is different from a concrete facade. So we do have opportunities coming. However, we have to also bring in and develop the capabilities and capacities in country to be able to use those new materials. And ultimately, we have to think of structures as also carbon sinks. You know, everything we do now is very carbon intensive. So what if our homes and buildings can become, you know, we call that biogenic. So the materials that we use can actually sequester and capture carbon during its lifetime. So these are carbon capturing surfaces and materials. So that's where the industry is heading and has to go to achieve 1.5 or anything between 1.5 and 2 degrees.
You have touched on my research area of carbon negative materials, but it's a shame we don't have the time. Cross-laminated timber is a really interesting material.
Sure, thank you. Just exactly like Engineer Hadi is talking about, lightweight construction, clearly it's a future, current and the future roadmap. And we're certainly looking at this very closely. We are actually looking at reducing the board weight, which we used to be about 8.3, we are about 7.3 now. Reducing even the galvanization from 200 to maybe coming down to 150. This certainly helps in both operational and embodied carbon footprint. At the same time, recycling the water waste within the plant. This also is it's a short term, but it will be certainly become a long term. And we pass on this savings to our end users. This is the key behind this. It's not just internal saving, but also when you make this major steps within the organization, then you certainly pass on this leverage price factor to the customer. I think what we see is the skills. Once again, how do you use the skills on the construction side? I think traditionally, this is one of the oldest industry. The skills are still 30-year-old. We need to change that. And I think for that, we have a lot of training centers being developed within the region. We can see that. So that this can be automated, maybe even digitalized to a certain level, provide the latest know-how, latest tooling, methodology to reduce the waste at the site, comply with the recent regulations and the greenfield building materials. At the same time, how do we harness the recycling? You know, circular economy is the key. I think this is probably one of the biggest part here in the construction industry. How do we collect the waste from the sites? How can we reuse it back again? This is missing. And that's why I was saying, I know we are an importing nation for raw material. And there is still a huge scope in this field today to use, to apply circular economy, but whether in steel, whether in the cement or the gypsum, I think there's a huge scope. We need to work together on that.
Yes, recycling is definitely one of the ways forward. Eventually, every building will get to the end of its life. Eventually, it will be demolished. We need to have something that we can do with that demolition materials to bring it back into the system. That's a fascinating area. You also touched on something that I want to move on to, which is the costs element and the legal side, which is the final element of this. Cement, concrete is a very cheap material, and it's a very useful material. So when we're looking at new lower carbon materials or lower footprint materials, we are often looking at something that is more expensive. Is it a case that we work on the technology until it becomes less expensive? Or is this something that is going to require legislation to move towards the lower carbon materials?
Okay, for the cost and turning into sustainable world, this need to be enforced. This need to be empowered by government, by a real will. And we can have this an example for the Russian-Ukrainian crisis, that now European countries give a deadline to stop using oil and gas. Right now, only right now, because we have a threat from this part politically. And if the countries of the world realize that the climate change will cause fires, floods, disasters, this will cost billions. So we don't want to think that we need to make money from the material on a short term, while the country itself, each country will suffer disasters from the climate change. So we need to think that climate change is a threat, will cost money, which now we can avoid if you invest in the right direction.
So more on the government side and less on the industry side. What do you think?
So then I have to say the opposite. I'm going to say more on the industry side. Certainly regulation can nudge us in one direction, but it's also a question of supply and demand. So one of the reasons why cement is so cheap, because it's so abundant, and these are very old industries with very high liabilities. So when we're now moving in with alternative materials, clearly there is some elbowing in the market. And for lightweight facade to take a stake of that in the market, and in the future cross-laminated timber, etc., there is an issue related to supply and demand. So the more demand there is for it, there's going to be more supply, and that supply is going to drop in price as well. So we have to enable it, right? This is where we perhaps need to nudge it so that we can enable alternative materials to penetrate the market and become competitive. In our case, 1,500 square meters of lightweight facade, the price difference with precast or blockwork facades was about 3 to 5%. I mean, it's a small price to pay today for being innovative and being low carbon. And I think it's only going to become cheaper and more competitive to be low carbon in the future.
I think there's a lack of communication here, actually. Not through the industry. I think it's overall in the spectrum. Why? Because the end user is not fully aware what's available today. So we are actually giving them what we have. What are the options for the end user to make those decisions in terms of the material and the thermal conductivity and the recycling content, and how much he or she is going to benefit from this, the end user? I'm not talking as a developer, I'm not talking as a manufacturer, I'm actually talking the single dweller in that apartment, in the units, who's actually going to use this. They're not aware of these things. I think those are the decision makers in this whole chain. We need to bring them on board as well. We also need to employ the SMEs here, which are the decision makers again. They are the one who's promoting these products at the medium level, and they're not visible. So yes, we can certainly implement from our level, but I think they are the key players. They are paying the value for this, but they're not aware is it sustainable in the long term? Am I going to get any benefit as an end client user of this or not? I think this is missing, what I feel from my perspective. But at the same time, it's a larger task for everyone to do this. So how do we do this? We cannot just put the weight on everything on the government. I think government has done enough. I think, again, I go back to the manufacturers and the key players in the value chain. Where are we in this? How are we going to measure the KPIs of this? Clearly, 2 days were great. What is next? I'm going to go back home with my kids and family, with my pets. Normal day again. The KPIs, where are they as an organization to leverage the sustainability we're talking about for the last 2 days? Yeah? So, great event, to be honest. I love it. And I had a lot of information to them taking on board, and we're going to work with my team and my dealers and the contractors to imply this. But I think one is not going to make that big difference. We need all the stakeholders together to make that thing happen so that the end user can actually really benefit from that.